Okay, so we are going to be doing numbers 33 through 36 on the multiple choice portion of the review packet. So number 33 starts with a softball that is popped up into the air with the initial velocity of 43 feet per second. Its height, h, in feet after t seconds is given by that function right there. So how many seconds does it take the softball to reach its maximum height? So what you want to do here is find the vertex. To find the vertex, you can do your negative b over 2a to find your x coordinate, which in this case is called t. Or if you'd like to use your calculator to help you, you can go to your y equals feature on your calculator, type in your function, again using x instead of t, check out your graph, and you'll see that you can't see the maximum on your screen, but you actually can use your calculator to calculate it still if you want to. Or you could take a look at your table, second graph, and look for your highest point. And the highest point I see here is 32. So that doesn't mean that's the maximum, it just means that gives me a little bit of a scale as to how high to change my window. So I'm gonna change my window, y max, to be like 45 just to be safe. And then I'll hit graph again. And there we go. So if you'd like to use your calculator and you don't want to use this formula by hand, you can do second trace maximum. Your left bound, just make sure you are to the left of your maximum and press enter. Right bound, you can just arrow somewhere to the right of it, enter. Guess, that's where you should guess where you think it is and press enter. And then I will just round this to the hundredths place. So my vertex is 1.34 and 33.89. So if that's my vertex, it wants to know how many seconds it will take the softball to reach the maximum height. So t is like our x, that's our time. So I'm going to say approximately 1.34, and don't forget your unit, which is seconds. What is the softball's maximum height? So that goes with our y value, which is h of t in this function. So that's going to be approximately 33.89 feet. The second part, B, is very similar. This is talking about a quarter flipped into the air with an upward velocity of 8 feet per second. So I'm going to repeat those steps for this problem. Going back to my y equals, typing in the function, checking out the graph. I still have the window set from the last function, so you can always do zoom 6 to get back to your standard window. And then I will second trace for my maximum. Left bound, right bound, guess. All right, so it looks like our vertex for this problem, I like to just jot it down so we have it here, is 0.25 and 6.5. So for how many seconds it will take, we're going to do 0.25 seconds, our t value, and then the maximum height is that height that it reached, which is 6.5 feet. Okay, 34, which graph is a representation of exponential decay? So for this problem, we have to think about what we know about exponential functions and compare them to quadratic as well as linear functions. So what I'm looking at here is I see exponential growth because the graph is increasing from left to right. So this is growth, so that is not one of them. What I have here is decay, because it decreases from left to right, and that's what this is asking for, so I'm going to bubble this one in. It doesn't say select all that apply, but just to be sure, I'll double check these. This is a straight line, we know this is linear. And then this is a parabola, the U-shaped graph, so we know that that is quadratic. All right, 35. For 35, which graph is, or graphs, it does have that, is not a representation of an exponential function? Select all that apply. So similar to the last one, this is a parabola, which means it is quadratic. So that means it is not exponential. So I will bubble that one in because the key word here, bolded and underlined, is not. All right, this one is going to be exponential growth. We know that shape. So if it's exponential growth, increasing from left to right, that's okay. We don't bubble that because that is an exponential function. This one, we just talked about decreasing from left to right. That was what we were looking for in the last problem. So that's exponential decay. So that one's okay. And then again, straight line, linear. So that is also not a representation of an exponential function. Number 35 is also talking about exponential functions here. Sunflower sprouts double every week, and they started at 0.5 of an inch. How tall will the sprouts be after 28 days? So we always use our exponential function starting with y equals a times b to the x power. And we have to decide, a is our initial value, so that's going to be our 0.5. B is going to be, if it's doubling, tripling, etc. So since it's doubling, that's going to be 2, and then to the x for now. That would be our function. But it wants to know how tall it's going to be after 28 days. So you have to decide. It says every week. So if you think about it, there are 4 weeks. I'll just write this as a note to the side, in 28 days. So that means I'm going to write 0.5 times 2 to the 4th power. That's our x value. So you could type that into your calculator if you need to. Exactly how you see it. And you're going to get, it's kind of in the dark there, but you're going to get 8. Now you have to think about what your unit should be. So how tall will the sprouts be? So that's going to be inches, 8 inches. And for B, 50 ants are left undisturbed in a local park. They triple every 3 days. How many ants will there be after 18 days? So again, we're starting with our exponential function. Our initial amount is 50 because there's 50 to start. And then we're also going to use the fact that they are tripling for our B, so that's our 3, to the x. But it wants to know how many there's going to be after 18 days. And they're doing this every 3 days. So you have to think, how many sets of 3 days are in 18 days? So there's 6 sets of 3 days in 18 days. So that's just a little side note. That's going to be our x. So y equals 50 times 3 to the 6th. So if we type that into our calculator, in the light there, we are going to get a lot of ants, which is 36,450 ants. Okay. And the last problem for this video is 36. So in 36, we're talking about what is the exponential function that we see in this table. So again, I'm going to go off of our formula here that we used in 35. And we are trying to determine our a value and our b value so that we can write our exponential function. So first of all, we know our a, our initial, our original amount, is always when x is 0. So that means our a value is going to be 1 in this first problem here. To help find the b value, you want to determine what you are multiplying by to get from one y value to the next y value as you move across the table from left to right. You can also figure out what you are dividing by as you move backwards in the table from right to left, whichever works for you. So I know that I'm multiplying by 3 to get to each of these. So that means that b is 3. So if you plug that into this formula here, you're going to have y equals 1 times 3 to the x. However, we know we don't have to write the 1 as the coefficient there for a, so we're just going to write y equals 3 to the x power. And then our last problem is b, right here. So for this one, again, our a value is going to be 3. And we're determining what we are multiplying by to get from y value to y value in this table. And what I'm noticing is that it has to be a fraction because the numbers are getting smaller. So if it helps you, remember, you can always work backwards. So like I was saying, you can work from right to left and divide. So for instance, you could do 3 divided by 27 if you weren't sure. And then you can always turn it back into a fraction if you don't already type it in as a fraction. Whatever works for you. You can also do 1/3 divided by 3. Turn that back into a fraction. Okay, so that means our b value is going to be 1/9. So when we plug this into our function, we get y equals 3 times 1/9 to the x power. And that is our answer for 36b.